Good day to you all. You are welcome to this class. Kindly subscribe to my YouTube channel at Eastward Mathematics C 12291, and also follow my Facebook page at Prince Eastward Online Mathematics Class. Today we'll be looking at how to find a solution to a question on circle theorem. Circle theorem is the properties that show the relationship between angles within the geometry of a circle. I take it again. Circle theorem are the properties that show the relationship between angles within the geometry of a circle. Now, for you to solve question on circle theorem very well, circle geometry, you need to have a full understanding on how to deal with angles, such as sum of angle on a straight line, which is 180 degrees, sum of angle meeting at a point, which is 360 degrees, sum of angle in a triangle, which is 180 degrees, sum of angle in a quadrilateral, which is 360 degrees. So, if you are dealing with circle and you are asked to find the missing angles, it is important you remember what you have learned under angles, and once you are able to recollect this, you have a full step ahead in solving questions on circle theorem. Having recollect what you have learned on angles, you need to also know some theorems that will help in solving questions on circle. Look at this diagram very well. It comprises of a circle and a quadrilateral. The quadrilateral touches the circumference of the circle at 4 different points: here, 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 and here. When we have this type of when we have quadrilateral drawn within a circle touching the circumference of the circle at different points, we call it cyclic quadrilateral. So this shape is a cyclic quadrilateral. And from the instruction, we told that angle AOC equals 136 degrees, angle ABC equals to 8 degrees, angle ADC equals to 6 degrees, and reflex angle AOC equals to B degrees. Find the missing angles. The AOC I have here is different from the reflex AOC here. This is an obtuse angle, that is angle less than 180 degree but more than 90 degree. Why this is an angle greater than 180 but less than 360 degree. So let's begin with the solution. Like I said earlier, to solve question, to find the missing angle in this diagram, we need to use one of the theorem in circle geometry. And the theorem states that the angle at the center is twice the angle at the circumference. I take the theorem again. Angle at the center is twice the angle at the circumference. Theorem. The angle at the center is twice the angle at the circumference. From this theorem, there are some important words that you need to understand before you begin to solve. The angle at the center is twice the angle at the circumference. There is a key word here, angle at the center. What is an angle at the center? Angle at the center is any angle that is formed at the center of a circle. Angle at the center is any angle that is formed at the center of a circle. Another important statement you need to understand here is angle at the circumference. Angle at the circumference is any angle that is formed at the circumference of a circle. Angle at the circumference is any angle that is formed at the circumference of a circle. And don't forget, circumference is the distance around a circle. And this theorem is telling us that angle at the circumference is twice. When we say twice, twice means times 2. The angle at the center is twice the angle at the circle. That is, if you want to get the angle at the center, when you are given angle at the circumference, you multiply the angle at the circumference by 2 to get the angle at the center. Now, let's identify our angle at the center and our angle at the circumference from the diagram. Angle at the circumference from the diagram, we have this angle B, which is small letter A. This angle B, labeled as small letter A, is an angle at the circumference. Likewise, angle D is an angle at the circumference. These are the two angles at the circumference in this diagram for now. Meanwhile, we also have this angle A, but you are not given that side, you are not asked to look for it. If you have an angle here as well, you draw an angle, that means this one is also an angle at the circumference, this is also an angle at the circumference. Because you are not given that and you are not dealing with that, so the angle at the circumference from this diagram is just this angle B, which is labeled as small a, and angle D, which is labeled as well small c. Likewise, the angle at the center from this diagram are also angle B and that of what? Angle 136 degree, the angle at the center. Now, another thing you should know that which angle belongs to, and what is the respective the center of each angle at the circumference, in the sense that because there are two centers there, angle 136 and B, one belongs to each angle at the circumference. So the center of angle A is 136 degrees. That is the center of angle A, 136 degrees. Also, the center of angle C is 100. The center of angle C is B. The center of angle C is B degree. The center of angle C is B degree. Now, this thing for theorem is telling us that if you are given angle at the center and you want to get angle at the circumference, that is, we are given angle at the circumference and you want to get angle at the center, you multiply the angle at the circumference by 2 to get the angle at the center. Now, in a reverse statement, this theorem can as well be changed, because it's not every time you be asked to find the angle at the center. Sometimes you can be given angle at the center as well, and you'll be asked to find the angle at the circumference. To find the angle at the circumference, when angle at the center is given, you divide the angle at the center by 2, which means that the reverse of this statement, this theorem, is angle at the circumference is half of the angle at the center. Take it again, angle at the circumference is half of the angle at the center. Because that anytime you are given angle at the center and you're looking for angle at the circumference, you divide by 2. While if you are given angle at the circumference and looking for angle at the center, you multiply by 2. So now, from this diagram, I'm going to find the value angle of angle A first. You check very well. Angle B, which is center of C, is unknown, and C is unknown. When you check angle A, it has its own center, which one is it, and that will make it easier for me to get angle A easily. That is, to get angle A is A equals to 136 degrees divided by 2. And that is 68 degrees. Mind you, don't forget your reason. What is the reason? Angle at the circumference is half the angle at the center. So that's our reason. So A equals to 68 degrees. Now you are left with two missing angles, which is B and C. To get C, you need to know the value for B. And when we check the diagram very well, you see that angle 136 and angle B meet at a point. So for us to solve this very well, we are going to use our knowledge of angle meeting at a point. The sum of angle meeting at a point. That's what we are going to use to solve this particular question, to find the value for B. That is B plus 136 equals to 360 degrees. Reason: angle at the angle meeting at a point. That is, the sum of angle meeting at a point is equal to 360 degrees. Then we now have B equals to 360 minus 136 degrees, and that gives us 224 degrees. So our B is 224 degrees. And since our B is 224 degrees, which is the center of angle C, then you can as well use the same knowledge that we used to solve angle A to find C. And to get C, let us C equals to 224 divided by 2. Reason again, angle at the circumference is half the angle at the center, and that is, we divide 224 divided by 2, 112 degrees. So which means our angle A is 68 degrees, our angle B is 222 degrees, our angle C is 112 degrees, and that is the end of the solution. Don't forget to subscribe to my YouTube channel and follow my Facebook page for more exciting videos. Thank you. See you next class.